And what we're going to do today is solve exponentials. Doesn't that sound fun? Well, first of all, what is an exponential? This is an exponential equation. Why is it an exponential equation? Because it has exponents. Everything that has exponents is not an exponential equation. This has exponents, but it is not an exponential equation. Why is that one an exponential equation and this one is not? Yeah, it does have an exponent. The variable is the exponent. That's why this is an exponential equation, because the variable itself is the exponent. And so, does it make sense that if the base numbers are equal, the exponents are going to have to be equal in order to have an equality? Does that make sense? What is x going to be equal to in this example? X is 5. Doesn't that make sense? That if the base is equal, the exponents have to be equal. So in this one, the bases are equal, so the exponents have to be equal. So what's x? Is that hard to figure out? Even this one, the bases are equal, so that means that 2x has to equal 8. So what is x? 4. You think it's going to get harder than that? Yes, of course. But what if the bases are not equal? You make them equal. You take charge of your numbers and you make those bases equal. Do you know that 9 is equal to 3 squared? And so I can replace the 9 with 3 squared because they're equal. I still have the power of x. Over here I still have 3 to the 5th power. Now do I have bases that are equal? Both of the bases are 3. Then I have to remember some exponent rules. The exponent rules say that you multiply those together when you have a power to a power. And then the 5 would have to be equal to a 2x, right? Equals 2x, divide by 2, and x is equal to 5 over 2. Often in these kind of problems, you will not have whole number answers. You will have fraction answers. That's going to be okay. Okay, now look at your gold note paper. Gold note paper, it says just what I was explaining to you. Exponential equations have a variable that is an exponent. This is an exponential equation. This is not. They both have exponents, but in order to be an exponential equation, the exponent has to be a variable. And just like I was saying, in order for these exponential equations to be equal, first the base has to be equal and then the exponents have to be equal. So let's look at example number 1. The bases are not equal. First, I need to have the bases equal. Can I replace that so that the bases will be equal? Is 2 squared equal to 4? You have to replace it, substitute in something that is equal. then you have to remember your exponent rules. Your exponent rules say that you multiply the exponents together. Once the bases are the same, then the exponents must be equal. The bases are the same, so the exponents must be equal. Can you solve that equation? How about if I subtract x from both sides? And then that would be x equals -3 for your answer. Okay, everybody got that? Anybody still copying? How? What? Right here? Is this the 2x you're asking about? The exponent rule says when you raise a power to a power, you multiply those together. That's where the 2x came from. The bases are equal, so you don't have to worry about the bases. You just have to worry about making this exponent equal to that exponent because the bases are already equal. Okay, so how do you check? How do you check anything? You go back to the original equation. What was our answer that we just had? And so if I plug in a -3 in place of x, I would have 4 to the -3 equals 2 to the -6. And so then you would take your calculator, and with your calculator, can you put 4 raised to the -3 power and 2 raised to the -6 power, and did you get the same decimal number? And so that does check out. Oh, I just wanted to mention something else. I had some people do this. They said the base is 4, so I'm going to change this to base 4, so this needs to be 2 squared. Is that okay to do it that way? Well, think again, because is this equal to that? You can't substitute things that are not equal. This is not correct because this is not equal to the 2. Do you see the difference between what we did originally? This is correct because this is equal to the 4. You can replace it. You can only substitute things that are equal. So you can't substitute a 2 squared here because it's not equal to 2. Okay, so example number 2. On example number 2, the bases are not the same. So we have to make the bases the same. I understand that some of you don't have a lot of multiplication skills, so you can use a chart. Now, this chart is different than just a regular multiplication chart, because on a regular multiplications chart, you would say something like, let me get my pen. You would say 4 times 3 is 12. Well, that's not what it does. This isn't a multiplication chart. This is a power chart. And so what this means is right here, this is 2 to the first power, and 2 to the second power, and 2 to the third power. This is 3 to the first power, and 3 to the second power, and 3 to the third power. So do you see how the chart works? It's a power chart, not just a regular multiplication chart. So right here I have a 9, and right here I have the 27. So the 9 is 3 to the first power, 3 to the second power. The 9 is 3 to the second power. The 27 is 3 to the first power, 3 to the second power, 3 to the third power. And so then I don't need my multiplication chart anymore. And then I have the x minus 2 is still over there, and the 2x is still there. Do you understand where 3 squared came from? It is equal to the 9. 3 to the third power is equal to the 27. So I substituted them. And then you need to multiply the power to the power. That's your exponent rule. 2 to the 2x equals 3x minus 2. The bases are the same. You see the bases are the same? If the bases are the same, then the exponents must be equal. 4x equals 3x minus 2. You have to distribute. To finish, subtract 3x from both sides, and x equals negative 2 is your final answer. And if you wanted to check it, you would put it in there and substitute it in order to check it. Now, question? Oh, let's back up. Back up. I made a multiplication mistake. Right there. What is that supposed to be? 6. And so then, when you subtract the 3x, that's going to be x equals negative 6. Is that better? Okay. Thank you. All right. Before we go on to the next example, I would like you to go look at the homework paper. I want you to complete problem number 1 and 2 on your homework paper. Right now, problem 1 and 2. The 5 is right here. The 25 is right here. That means 25 is 5 squared, if you didn't already know that. So far, so good? What's going to happen here on this one? I keep thinking I made a mistake. Where? I'm getting it mixed up with a different problem. How about right there? Is that better? All right, and so then when you are solving an equation, what are you trying to find? You are trying to find out what x is equal to. The answer is x equals 2. Does that answer what you were asking? Okay. Good? So far, so good? Because now we have to do the hard problems. So now that we finished the easy problems, we have to look at the more difficult ones. So would you please go back to your note paper? Please look at your note paper. What makes this one more difficult is the 1/2 fraction. And I have shocking news for you. In order to do this problem, you actually have to remember the negative exponent rule that we did 3 or 4 weeks ago. Can you believe I am expecting you to remember something we did 3 weeks ago? Yeah. Okay, good. Did you remember it? Okay, let's see how this works. So, this has a 2 in it. Can 8 be changed to a number that is base 2? Here is the 8 in my chart. That's 2 to the first power, 2 to the second power, 2 to the third power. 8 can be written as 2 to the third power. So up here, 8 is, no, not 8. 2 to the third power is equal to 8. But what do I do with a 1/2? Because I know the exponent rule, I know that a fraction can be changed to a negative exponent. 1/2 is equal to 2 to the negative 1 power. 1/2 is 2 to the negative 1 power. A fraction is a reciprocal. The 1/2 is a reciprocal of 2, and 2 to the negative 1 power indicates reciprocal. Now that we have the bases the same, you multiply these together and you multiply those together by the product rule. See if I can do this without messing it up. The bases are the same, so 3x equals negative 1 times x plus 4. 3x equals negative x minus 4. In order to solve that, I'm going to add x to both sides to get 4x equals negative 4. Then what am I going to do with the 4's? And so x equals negative 1 is your answer. If you have a fraction, you change the fraction into a negative exponent. Let's try example number 4. Example number 4 has an 81 in it, and it also has a 9 in it. 81 is 3 to the first power, second power, third power, fourth power. 81 is 3 to the 4th power. 9 is 3 squared. 9 is 3 squared, but it doesn't say 9. It says 1 over 9. So to make it a 1 over 9, you make that into a negative 2 instead of a positive 2. And then the power rule says that you multiply those together and you multiply those together. So we have 4 times 3 minus x. And we have negative 2 times 5 minus 6. Can you distribute and finish solving? I'm going to add 10x to both sides. What am I going to do with this 12 right here? To get rid of this 12? What happens when I subtract it? It's 0. And so x equals 0 is your answer. 0 can be an answer. It does not mean that the answer is no solution. It means that the answer is 0. We are going to finish the rest of those notes tomorrow. At this time, you are going to finish worksheet, or at least work on worksheet 9.5.